nerd. And this nerd is going to show you how to find the volume. And I'm recording, so I hope y'all will keep it clean. I've already cussed, so that's out of the way. Just kidding. Well, kind of not kidding, but anyway. So we have some really good drawings here on your paper of what it looks like when something is rotated around the x-axis and when something is rotated around the y-axis. You get all kinds of groovy shapes. I know, right? This is, down here, is a better example of the disc I was trying to relate to you. If we take a rectangle that we can find the area of, and we spin it around the x-axis, then we can find this volume. It is pi r squared times the width, right? And the radius now of that disk is f of x. So we basically do pi times f of x squared dx. And we do the integral of that. And that adds up all of those disks that this is basically cut into to find the volume. Does that make sense? Yeah. The radius is the function. Like how far away from the x-axis it is at that moment.
It's like the area under the curve.
So we're taking that whole area and we're rotating it. This little piece right here, becomes a disc.
Yeah, but doesn't it change for each point on the...
Yes, this height is f of x. This height is f of x. And it depends on where you are along the x-axis. So the radius is the function we have, the f of x, and the y values of that function.
How do you do this without using the x-axis?
Because all we're doing is taking the area and rotating it. That's a really good question. We are diving into 3D objects, but we're not using our three-dimensional plane. We are just staying with our x and y axis, and we're just rotating. So the integration finds the volume of the rotation, or a solid of revolution is what it's often referred to as. Okay, so this is written a little bit better than I did right here.
It's a more
but you're basically doing pi r squared. People will forget the pi. Don't forget the pi. Okay. People will forget to square the function. Don't forget to square the function. Pi r squared. Because again, you're finding this disk right here, and the area of the side of that disk is pi r squared, and then the width of it is dx. Does that make sense? These are pretty good visuals right here on this page 1.
And this is how you find the volume of the cone.
Yes, you can find all. Actually, you're going to see where our formulas came from in the first place. But before we do that, let's take a basic function, okay? And this is a nice function because it's just y equals x. We love y equals x, right? Your basic linear function. So we are going to rotate this. And by the way, I hope you can really kind of visualize that shape. Since it is cut off, this is not a cone. It is a what you call a truncated cone, meaning the end is cut off. And are you thinking, like, Does anybody have like an old-timey thing to plug up the bathtub water? Like just the little rubber piece that, and does it not taper?
Yes.
The little stopper is this shape right here. Okay, now think about it. There is a shape somewhere in your automobile that functions kind of the same way. There's plenty of washers. We want them made of good materials, and we want them to fit precisely. So again, a machinist that makes those parts for cars and lots of other things in this world would be concerned about the precise measurements and things like that. So most machinists don't even have a college degree, but they are doing calculus, which was a surprise to me. But yeah, they actually knew more calculus and geometry than even I had stopped to think about at times. So it's an interesting tidbit. Anyway, so what would we do with this? Do y'all want to put the pi in front?
Yes.
Pi in front.
Pi in front? Okay, pi times the integral from 1 to 4 of, okay, it's y equals x. So the x value is the y value. Y equals x. So it would be x squared.
Teachers, I apologize for the interruption. We have just had a late bus arrive. Those students are now coming to class with a green pass. Please admit them to class. We have had a late bus. Please admit these students with the green pass to class. Thank you.
Wow. Okay, so let's do this relatively easy one by hand. However, setting these up on your calculator is also a handy tool. And I know on this test, I will have you do 1 or 2 where you need to give me an exact answer. For example, Matthew, I'm not just picking on you, but I know you've done this before. And an exact answer would be 8/3, not 2.66. Okay, and you can only really arrive at that by doing it by hand. Okay, or technically you could turn that into a fraction yourself. But a square root, I would never be able to create that from a decimal. Makes my brain explode thinking about it. Anyway, so integrating x squared, we get x cubed over 3. And we are going to evaluate that from 1 to 4, and we're going to multiply by pi in front. So this would be pi, and then 4 cubed over 3 minus 1 cubed over 3. And so that would be 64 minus 1 is 63. I'm so smart. Yeah. And then, so what is 63 divided by 3? 21. The volume of this shape is going to be 21 pi. Nice, pretty number, right? If you set this up on your calculator, what I would suggest is leaving pi out. This right here would give you 21 on your calculator, and you would just need to know that that means 21 pi. Yes, sir?
Couldn't you just divide by pi too? Number.
Divide by pi. What?
So if you put pi in there, and then
Oh, gotcha, and you got some ridiculous decimal.
Yeah,
Gotcha. Sure you can. I don't know if some digits would get lost in there.
I can try it.
Huh? Maybe.
If you get 20.0000,
Right.
20.99999.
Right.
Your profit's probably good.
You're right. So, isn't that kind of cool to find the volume? I love finding volume. It makes me feel so grown up. Ooh. Look at this little guy. Looks like a fancy, let's look at this. Looks like a fancy wine stopper, whatever. Anyway.
Very precipitous table.
Say again.
Looks like a dangerous table to me.
A dangerous, precarious table, yes. I like that. Okay. Sure.
Precarious is the right word. What does precipitous even mean? Yeah, you can.
So, Camille's a busy girl today. So, apparently this is x squared, y equals x squared. And we are going from 0 to 5. Now, I need you to look at something, okay? And it's the verbiage. And IB is very big on this verbiage. It is revolved through 2 pi about the x-axis. What that means is, it just means that is a full rotation, okay? It does not mean that we multiply by 2 pi, okay? Matthew, are you paying attention? Okay? I hate to be picking on you, but you're the very person who would do this, thinking it says 2 pi, so I must need to put 2 pi in front of it. No, it just means a full rotation around the x-axis. The area of that disk is still just pi r squared, okay? Because it's a full circle. Yeah, Camille?
So if we were to have to deal with different values, like only rotated, like
Okay, so ours, all I have seen in the land of IB is a full 2 pi rotation, okay? But yes, the idea is you could limit that and just have like half of the 3D shape. Or a quarter of it, or, whatever.
But that just adds the extra step of
Yeah.
dividing by how much that is.
Correct. You would,
Sphere.
You would just cut that in whatever. You would just divide, yes.
Whatever portion of the circle it is.
Right. Kind of like we did area of a sector.
Or like area
And it
of the-
depended on theta, but really that was a relationship between theta and the full circle. So, yeah, it can be done, and it can be easily done. I've just never seen it in the land of IB. Okay? Good question. So this would be pi times the integral from, it did say 0 to 5. And this would be x squared squared. Okay? And then dx. Are you all clear on that? X squared squared. So it would be x to the 4th. And then when we integrate that, that'll just be x to the 5th over 5, which would be pi times, oh hell, I don't know what, 5 to the 5th?
5 to the 5th is whatever 625 times 5 is, but you're dividing by 5.
Correct. I see where you're going with that. This would technically be 5 to the 4th power.
Since,
Right.
well, not that specifically, 5 to the 5th divided by 5.
Correct. That's what I was pointing at.
Yeah.
This would be 5 to the 4th power. Does that make sense? Well, no, only because we're plugging in 5. So in other words, we're doing 5 to the 5th over 5 minus 0 to the 5th over 5. And 5 to the 5th over 5 would be 5 to the 4th pi, or 625 pi. Right?
Yeah.
125 times 5 is 625. Yes.
That is a lot of time.
That's a lot of pies. That's a lot of pie right there.
Do we have to write?
As long as it's pumpkin, I'm all about it.
Do we
So,
have to write
Yeah.
units?
What if it's down?
I mean, no, actually, I was just telling year one that, like, no, IB is not a stickler about the units. But those of you in chemistry, I would tell you to cling to those units. The units make you safe. Do the units in chemistry not help you know what in the world to do in chemistry? Like,
In physics, they definitely do.
Exactly.
They're literally just equations of this
Correct.
basic constants.
Correct. In chemistry and physics, now I remember that, I clung to those units. Ironically, in math, I'd be like, yeah, centimeters, whatever, yeah.
It's just a little more. It's like if you put the wrong units, you don't want to mark it wrong.
Yeah. The brown ones on that second basket on the closet there.
Units are what saved me when I did thermodynamics. It's like a hobby. Because specifically,
Absolutely critical in those classes.
Specific heat,
Yep.
SI units, yada, yada, yada. And that's literally just the equation.
Okay, so again, this would be from 1 to 2. Oh, is it a bunch? What have you done?
I do not like the fact you write the numbers on the right side of the integral and not the left. That would just be x to the sixth.
Okay, guys. Okay, both of these are pretty straightforward, and you do 2 to the 4, and then actually, I just don't think you probably need all that much practice doing this. But so, are these correct? Ha! Very good. It would be pi r squared. Okay. Don't forget the pi. Okay. Yes. Because it's got to be pi r squared.
If we forget the C when we do the integral, are we going to disappoint?
I think if there's an indefinite integral on an IB exam, and you forget to put plus C, they may take off like 1 mark on the whole exam. So let's say you did that 3 times. They would take off 1 mark for like all of it. Not each, but just one total. Not a huge stickler on that. Now, the thing is, you guys will be doing some differential equations. And that is when you go backwards to find the value of C. But in very, very, very elementary terms. So that plus C is kind of critical in the workings in the method of that kind of problem. But, say again? Correct. Yeah, because you are finding the value. Yeah. So you can also use technology, meaning, do you all remember how to pull this up on your graphing calculator? Is it alpha and F2? What is that button? Is it window? Is it alpha window? Yeah, okay, alpha window. Okay. I forget. I look for the F2. But
F and F.
so on an old calculator, yes.
F2, but it doesn't.
The thing is, if you update the operating system, like connect it to another graphing calculator with an updated operating system, then it will shove those things into F1, F2, F3. Actually, not going to lie, matrices. I forget what's in the others. Oh, yeah, F4 is just bringing up the variables, the Y variable of your graphs. And then there's actually nothing in F5. So, like, do you see how it's not doing anything when I do F5? There's nothing in there yet. But on the next operating system update, they've left room for that. So, anyway, alpha, window, integral. Now, keep in mind, and really, okay, so here's a good rule of thumb. I would leave the pi out of any calculations I do on my calculator. And whatever I get, 17.7 pi, okay, if it was meant to be done with a calculator, then that would be fine. Leaving it like that, as long as you don't forget to put the pi. In that case, pi is not just a unit. That's a number. So you would absolutely have to remember it. But again, I don't actually type pi in the calculator when I do it that way. Okay. Again, x-axis. What you'd want to do here is, again, I would not put the pi in my calculator. I would do this in my calculator, the integral from 1 to 3.
It's very broad. Technology.
This is really, really important. Putting this in your calculator. Okay, what do I need to do to this function?
Turn it into parentheses. Yes.
So this is extremely important. When the calculator gives you you do alpha, window, and integral.
It gives you initial parentheses, but
you have to put everything inside the parentheses that it gives you. Okay, so you can't go like adding a parentheses like before those, but it will give you a set of parentheses, and you have to jam all of this and what? Squared inside the parentheses that it gives you.
Unfortunate news, it gives a rational number.
Yeah, it's creepy. But this is what I would put into the calculator, and then I would put the pi after it, when I got my answer. Okay?
Yes.
That's a pretty important piece. On your test, on the IB test and this test, there is one on your calculator that just says, no lie, 2 points or 3 points if you can just literally set it up on your paper and then estimate the volume using your calculator. Like, literally just plug it into your calculator. Okay? Because this would be punishment for something you've never done, to do this one by hand. It would just be ugly.
It would be awful.
It would be awful. It would be unpleasant. So this would be the type where you would just write it and then estimate it using your calculator. Okay? Now for the fun part. So what I have, so what we have here is a circle. Okay, guys, please look up here. Put your technology away. Matthew, Ben. And look at this. Well, it is a semicircle, okay? But the equation for the full circle, any full circle, is x squared plus y squared equals r squared, right? If the shaded region is revolved about the x-axis, and by the way, in this, this is from the Australian textbook. So they don't say through 2 pi. They just say revolved around the x-axis, and you can assume that that is a full revolution, okay, when it says that. What solid is formed? A sphere. Very good. No, nobody needs me to explain that, right? It's going to be a sphere. Use integration to show that, and here's the end of the problem here. You know that the volume of a sphere is 4/3 pi r cubed, right? Actually, that's somewhere on your formula booklet, but it's just, I don't know why that is one of the few geometric formulas that always just rolls off my tongue. The volume of a sphere. I don't know why. I don't know how I don't know. Anyway, but we can get to that using integration. Okay? So, I'm going to take this shape right here. Well, what is the equation for that?
X squared plus y squared over 2 equals r squared over 2.
What is the, no, I just want the equation for this top part of the equation here. So in other words, I want it in terms of x, meaning I want to get y by itself.
Oh, pi r.
So y squared would equal,
R squared minus x squared.
uh-huh,
So y equals the root r squared minus x
The
squared.
plus or minus.
Plus and
so the plus
But yeah, plus.
is the
Yeah.
top, and the minus would be the bottom. So actually this equation right here would be just the square root of r squared minus x squared. Not negative, because that would be our bottom one.
If you want the area of the top, that's also equivalent to r squared. 2 pi times r.
Actually, it would be pi r squared divided by 2.
Yeah, pi r
And
squared.
R is a constant.
Right.
Oh, yeah.
So, oh my gosh. Okay.
Yeah.
John, you're seeing it, aren't you?
No.
Yeah, John just said something really important in this particular integral that I'm about to make. Okay, the thing is, check this out. How far to the left are we going? Well, negative r.
Oh, left.
And to the right r. So this is going to be pi, because we're rotating, times the integral from negative r to r of this guy, r squared minus x squared squared. Okay, that gets rid of a significant issue, does it not? Yeah, okay. And then dx. Now, there will be a similar, you guys, I know you know the answer is 4/3 pi r cubed. Like, I know the answer, you know the answer, everybody knows the answer. However, you might be asked to do one similar to this with a different shape on the test. So please, please, I hope you're paying attention, because this will come up, okay? And that is the whole R thing. You're like, how do I do? I don't have any numbers, right? You do. It's just R is that number. It is a number. We don't know exactly what it is, but it is just a constant. Okay, so I need you to concentrate on, again, we have the integral from negative r to r of r squared minus x squared dx. Correct? Okay. I need you to integrate this. And I will get pi times, from negative r to r, of, what is this?
You could take out an R, right? No, you can't.
No.
It is R cubed over 3.
No. We are we are integrating with respect to x, not r. R is like 7. So, no, we don't take it out. Like, there's a number there, but it's just a number. Like, r squared would, okay, so if I say it's 7, then 49. So how do you integrate 49? You would do 49x. So it's going to be r squared x minus, now, that one is x cubed over 3. Okay? R is a constant. Like I said, that was like the most important thing. You just kind of said it accidentally, right? R is constant.
Yeah.
But that's one of the most important things about this. Okay. So, let's evaluate it by plugging in R and negative R. Another kind of a headache. So this would be, okay, if I plug in R for x, I would get R cubed minus R cubed over 3 minus
R minus R to the negative R cubed
so that would be negative R cubed plus R cubed over 3. Serenity now.
So that's 2/3 2R cubed over 3 times 2.
So this will be actually, so I can do, this will be positive and that will be negative, right? So it'll be pi times 2r cubed minus, what did you say?
No, it's 2R cubed over 3.
2r cubed over 3. Right?
The
2
first one would also be over 3.
I'm just adding r cubed and another r cubed, which is just 2r cubed.
Yeah.
Now, what is 2r cubed minus 2/3 r cubed?
4R cubed over 3.
It'd be like 1 1/3, which is 4/3 r cubed times what? Pi. Otherwise known as volume of a sphere, right? Pi r cubed, or 4/3 pi r cubed. Yes.
I did this a completely different way.
It's fine, but you need to know how to, so the method
Yeah.
would be to rotate it about the x-axis, which is this way.
Yeah.
Okay? But yes, you can arrive at it multiple different ways, but the instructions say to do it this way. Okay? So, and that's how it is on a question on your test. So be sure and follow that method. Okay?
Just define the whole process. The volume of something is the infinite integral of its surface area.
That's fine.
Set that up.
But always follow what it's saying. Yeah. Now, I'm actually gonna skip. Actually, do you want it? Skipping to the donut is not that big of a deal.
The toroid.
And yes, it is. Well, a torus or a toroid, just like a trapezoid. Another word for trapezoid is trapezium. Right? I know, fancy words, things like that. Okay. So this is really important to find the volume of something that is rotated. So imagine that thing I was rotating around the pin earlier, right? And let's say I'm just drawing a basic shape, okay? I can find the area of this with regards to the x-axis, right? I can do that. Now, think of this rectangle rotated, like this, around the x-axis. I know I can't really zoom out anymore without messing up my camera. But then do you see that it would be like a washer? Like a washer you put on the end of a nut, if you will, a bolt and a nut, right? So the thing is, this is not going all the way down to the x-axis. So we have to do top function minus the bottom function. Now, I know you can look at your paper. Do I subtract and then square it? Or do I square it and then subtract? Okay, you're looking at your paper, right? You're looking ahead.
Yeah,
And this is
just because like you're finding the area of that one.
volume.
Volume, yeah.
Uh-huh.
Volume of that one and volume of the other.
Correct. And the video, you're going to kind of lose out on this, but you're basically finding the volume of this line rotated, okay? And then you're going to subtract the volume of this. In other words, you're going to hollow out that disc that you just formed. So you're doing the function squared minus the function squared to take out the middle part of it. Does that make sense? Who can help me? I need an equation. Well, do you want to do the torus? The donut?
Yeah.
Well, if we're going to do that, then I need an equation for this. Since we are rotating around the x-axis, we can just see, here's what's going to happen. Actually, I'll try to draw this guy down here, okay? Okay. I'm going to do the top of this circle, square it, which means I'll have all this volume here. And then the bottom of the circle, square it. That means I'm going to take out that middle part. I'm going to hollow it out. And this right here does that.
Is it for the same reason that it's like
You have diminished into nothing. What?
Because it was the big yesterday where it passed the test.
Yes. Yes, where we did the top minus the bottom.
Do it where it's like you take like I said, you flip it, you flip the for you to flip.
Make it opposite. Kind of. Yes. What were you going to ask, Ethan?
Is there a reason why it's called a torus?
Oh, shapes like this, these solids of revolution have shapes. And if it is a perfect circle rotated, then that particular name is torus. Most of them are Greek related, Greek or Latin related names, but yes, each of them is named depending on the regular shape that is being rotated, the regular solid that's being rotated. Anyway, so what is this equation
For the whole circle.
for this circle? Yes.
X squared plus y squared equals 1, considering it has a radius of 4.
Almost. X squared plus something squared.
Y plus 4 squared.
Y plus what?
Y plus 3 squared.
Y plus 3.
Oh, yeah.
Does that make sense? Actually, it would not be plus. What is that? It would be minus. Right. So I need to get that solved for y. Holy mother. This is worse than I remember it being.
Yes.
So y minus 3 squared would equal 1 minus x squared. Is that right? So then y minus 3 equals positive or negative square root of 1 minus x squared. So y equals positive or negative square root of 1 minus x squared plus 3 on the outside. Ooh, yeah, this one's kind of ugly.
And then we do the plus minus the negative.
Correct. Well, the plus squared
Yes,
minus the negative squared. So what we would do, I am not going to solve this. I'm just going to set it up. We would do pi times the integral from negative 1 to 1, because that's how far it goes to the left and right, of the square root of 1 minus x squared plus 3 squared minus negative square root of 1 minus x squared plus 3 squared dx.
Can we just type this into our calculators, please?
Right. That would be one that, yeah.
Use technology.
Yes, exactly. Exactly.
Right. Any technology.
I know, it doesn't say GDC.
UCLA.
It's not your GD calculator.
Pull out the
Hey, yeah, my slide rule is. Where is my slide rule, by the way?
You have a slide rule? Aren't those like
I have my dad's slide rule. My sister still uses hers. But yeah, this was actually a very fancy slide rule in the day. So yeah, isn't that exciting? Sure. Try not to break it.
That knows how to do
I do
this.
like it.
I don't know.
Who made it? Is it Royal?
It might be in the next one.
No. Tell me what that says. I can't read it anymore. Because I'm old. What?
So PICKELL.
This Y.
Pickle. Yes, ELL. That is just the equation. If the center by the way, you guys, are y'all listening? This right here, I got from doing, let's say the center is HK, then it is X minus H squared plus Y minus K squared equals R squared. That is the equation of a circle, and I'm actually wondering, so it is not on your formula booklet. However, it is like distance. It is very similar to your distance formula. Technically, a circle is every point equidistant from the center, so it's actually related to the distance formula. So that specifically is not on your formula booklet, but you can kind of remember it using the distance formula. John, what were you going to say?
Are we ever going to have to do the integral past volume?
No. We are not going to get into integrals of integrals and things like that. No.
That's how you get a volume of a 40 shape.
Yeah, we're not going to do
It's gonna be
that.
really handy for how everybody.
If you feel like your brain is exploding just thinking of that, then yeah, don't. No, that's not part of IB.
Yes, the four-dimensional
Yeah.
epihedron.
Mm-hmm. So what I'm going to do is, so what we've done so far, looking back at the very beginning, is all the different kind of rotations around the x-axis. And so I'd like for you to try these 6 problems. They are from the textbook. My apologies, Tyson, for textbook stuff. And I made, okay, for those of you still wanting digital, like double check. You have no idea how much time I spent on this, but double check that you can access the PDFs on Canvas. Okay? And so this lesson will have a part 2, which is rotating around the y-axis. Not that much difficult. I just thought, like, let's just kind of spread it into 2 pieces. Does that sound like a plan?
I calculate